Hey guys, um, so welcome to this malware analysis and reverse engineering lab. So far we have studied static analysis, and today in this module we are going to see dynamic analysis. So what is mean by dynamic analysis? What is mean by dynamic analysis process? So here we have seen, right, static analysis. We have been analyzing this malware without executing that malware. That is called actually static analysis. And in case of dynamic analysis, we are going to execute the malware in real time, and we are going to check the system changes and the behavior. So this is called actually dynamic analysis. So we are going to monitor the system changes and also the behavior. So that is called actually dynamic analysis. And here we are going to execute the malware in real time. So the process involves executing the malware in sandbox, and we are going to look out, we are going to monitor the changes. So what actually the malware is going to do? So that is the first thing we are going to check, and then how it modifies the system. Second thing we are going to check. The third thing is where it is going to connect over the network. So these are all the things we are going to see in this dynamic analysis process. So here in dynamic analysis process, we are going to execute the malware, and we are going to monitor the changes in the system. So what is the objectives of dynamic analysis? Is there any modification in the file system? I'm going to monitor. Is there any modification in the registry entries? I'm going to monitor. Is there the malware is going to connect some other person in the internet? I'm going to monitor the network traffic. So if the malware is going to generate some network traffic, I'm going to monitor. If this malware is going to auto start, it is going to be persistent in my system, I'm going to monitor. So if this malware do any going to do any launches of some process, then I am going to monitor. So these are all the objectives of dynamic analysis. So what it involves, what we can define elaborately. So if there is any changes in the files, if the malware often copies itself to a new location, downloads or drops new files, then the malware would create or modifies or deletes in the some files in the sandbox. So this is going to be a changes happening in case of if you have been considering the files. So in files, the malware, if I am executing the malware often copies itself to a new locations. Maybe the original file might be deleted, and it may communicate the internet, and it downloads some new files also, or the malware itself, it's going to drop some new files also. So while executing the malware may create a new file or modify the existing file, or it is going to delete the files in my sandbox. So this is regarding to the files. And regarding to the registries, if I am going to execute the malware often modifies the registries, existing registry entries. What is the purpose of going to modify this registry entries is the malware is going to hide itself, right? So this is one objective where this malware is often frequently it is going to modify the registry entries. So why it is being modifying these registry entries? To hide itself, or to change the security of the systems, or to maintain the persistence of the particular malware. So this is regarding to the registries. And regarding to the network, malware used to communicate over the network for what are all the purposes? So to download additional files, to exfiltrate the data, to connect back to a command and control CNC server. For connecting this CNC server, it may retrieve some information from the malware author itself and some network communications. So this network communication is the best way of detecting the malware in an organization. So we have to make a note on how the malware is actually going to communicate over the internet. So regarding to the network, if a malware communicates over the internet, so what are all the purpose it is going to communicate over the network? It is for downloading some additional files, or doing some exfiltrate data are going to connect with the command and control servers, CNC servers. So I mean the malware author. So and then regarding the process, if the malware is going to launch any new process and all, so we are going to monitor also. So there's four things we are going to monitor. I mean in the dynamic analysis. In the first part of the dynamic analysis, so in the dynamic analysis process, we are going to modify the file if there is any creation, modification, or deletion in the file, and we are going to monitor the registry entries also. If there is any modification in the registry entries, we are going to monitor. And if the malware while executing, if it communicates with the internet, we are going to monitor. And if the malware is going to launch some new process, then we are going to monitor, right? So what are all the points to be noted while doing this dynamic analysis process are? I'm going to give you some 3 points. You please make a note and do the analysis, dynamic analysis. The first point is prevent the malware from escaping outside the sandbox. This is actually a precautionary step. We have to consider this step. We have to keen into this step because we are dealing with the real-time virus. If I am executing my malware, real malware in my sandbox, it may communicate from the guest to the host. So for avoiding such conditions, we have to do some basic configuration in my virtual machine. The first basic configurations, what I have told in the earlier module of this laboratory experiments. So the first basic configuration is you have to configure your virtual machine as a host only networking mode. So we have done that thing and we have demonstrated that thing also. And then say preventing the malware. And the second point is you have to install a fake net to let the malware think it is actually in the internet, right? So we have to make to believe the malware which is actually present in the internet, so that it may communicate with some other host in the internet. So we have to install fake net, a simulator which will let the malware to think it is actually present in the internet. And third thing is don't map any important folders between the host and the guest. There is an option in virtual machine where we can share the folders between the host and guest. So please avoid sharing any important folders between the host and guest. So because we are actually executing the real-time malware. And the second point is user access control. So while executing the malware, you give full access, administrative privileges for all the tools what you are actually used for monitoring the malware behavior. So you give full administrative privileges for the tools you have been using for malware analysis. So this will give the full access over the system of that particular tool, malware analysis tool. Also execute the malware with UAC, user access control, so that we can see everything the malware what is actually it is doing in my sandbox. So the second point is user access control, where you have to give full access, administrative privileges to the tools, malware analysis tools used for malware analysis. And if needed, you execute the malware with UAC, so that we can see everything the malware is doing. The third very important thing is dealing with the 32 and 64-bit architecture, right? So maybe a malware coming into my system. So we are going to analyze, we are about to analyze that particular malware. That malware may be a 32-bit architecture application, or maybe a 64-bit architecture applications. Maybe my sandbox may be a 32-bit architecture OS, or maybe a 64-bit architecture OS. So while considering that thing, the 64-bit program, the program means any application may be a malware, or kept in Windows System 32 folder, as well as the 32-bit application programs are stored in the new directory called Windows syswav64 folder. So you keep a note on this folder, Windows System 32 folder. It consists of all the 64-bit programs, the supporting dynamic link library files, the portable executable files, every files, operating system related files, supporting files will be there in the System 32 folder. I'm talking about the 64-bit programs, maybe a DLL, maybe AXL. If it is a 32-bit DLL or EXE program, it should be stored in a Windows syswav 64 folder, right? So, for instance, if the malware is actually a 32-bit, it is going to execute on a 64-bit system, architecture system, then it has to load the libraries from syswav 64 and not from the system32 folder, because the system32 folder which loads with the only 64-bit DLL and application programs, maybe exe, maybe DLL, maybe sys files, everything. So for instance, if the malware is actually a 32-bit application, it is going to execute on a 64-bit architecture system, then it is going to load the libraries from the folder called syswav 64 and not from the system32 folder. So you keep these three things in your mind while doing the dynamic analysis. You have to, first point is you have to prevent the malware from escaping outside the sandbox. For that, you have to configure host-only network, and you have to make believe the malware think that it is actually on the internet by installing the fake net simulator, and do not map any other important folders between the host and guest. So this is the first thing. Second thing is user access control. Give full administrative privileges for the tools used for malware analysis, and if needed, execute the malware with user access control so that we can see everything the malware is actually doing. And the third thing is 32 and 64-bit architecture. So you have to you must know where actually the DLLs, the application programs, the supporting files have been stored for the different architecture of OS 32-bit or 64-bit. So if a malware is a 32-bit, if it is going to execute in a 64-bit application, for instance, it is going to load all the supporting libraries from the syswav 64, not from the system32, because system32 consists of all the 64-bit applications. Okay. So the next thing is malware persistent and autoruns. So while doing the dynamic analysis, this is very important thing. Malware is going to persist in your system if a malware being executed in your system, in your sandbox. So malware needs to figure out a way to auto start. So every time if I am rebooting, then the malware is going to do a persistent behavior in my system. So when the system reboots or when the user logs out and back in, the malware is going to persist in my system, and it holds the behavior of the autoruns. So autoruns is nothing but it is going to run automatically when the system gets rebooted. For this, the malware have to do something in the operating system for maintaining this persistent behavior. So usually malware author is considering two kind of technique for doing this behavior, malware persistent behavior or autorun behavior. The first one is the registry. Malware author used to create a malware in such a way that it will drop a registry keys, or it will modify the registry keys that will auto start the programs on every boot or every logon. So this is the first thing. Second technique may be DLL search order. So this takes advantages of the order which the DLLs are actually loading. So we are going to see in this coming up slides, right? So through the registry entries, so the malware author is creating the malware, and in such a way that it is going to modify the registry entries which is actually present in the system, so that it can do the malware persist through the registry entries. So these are all the most important registry entries. HKLM means HKey local machine, HKCU means HK current user. So under this, these are all the important registry entries where this actual malicious file will modify this registry entries for doing this persistent behavior of this particular malware. So you keep a note on this registry entries and all. The first registry entry is a very important registry entries: software, Microsoft Windows current version run, and run once, run services 1, Explorer run, and Windows NT current version Windows AppInit DLLs. So this registry entries, you please make a note. So most of the malware will going to modify this kind of registry entries for the persistent behavior. Right. The second technique is the DLL search order. So this is actually a DLL search order persistent mechanisms, and another name called a DLL search order persistent mechanism. So usually if a program is going to execute, say for example a malicious program is going to execute in a system, for that program it needs a DLL file, a supporting file, library file it needs. So for that DLL file, initially the operating system will have a search order, DLL search order. First it will search the directory of the program itself, right? Say for example C program files, the particular folder where the application been installed. So that is called actually directory of the program. It first search that DLL file. Say for example here we are having an application called program.exe. It needs an example.dll supporting file. So for executing this exe program.exe file, it first search the directory of the program. Program files, C program files, that folder it will search. If it is not present, that example.dll is not present, that supporting library file is not present, the OS will check the second folder is Windows System32 folder. Again, if it is not present in that System32 folder, it will check the Windows System folder. Again, if it is not present in the Windows System folder, it will check the Windows folder. Again, if it is not present in the Windows folder, it will check the current directory folder. Again, if it is not present in the current directory folder, it will check the full path of that particular system. So if it is not present in that directory also, full path of that particular system also, it will generate an error, right? It will generate an error. So the malware places itself, so a fake example of that DLL in the same directory as a program.exe. So this is actually this order, right? DLL search order is being performed by the operating system of your system, right? So this malware will make an advantage of this DLL search order, and it will place itself a fake example of that DLL in the same directory where it has been executed as a program.exe, right? So the operating system will find the fake malicious example of the DLL first, and it has been loaded. The program.exe will be loaded. So it loads a DLL later in the search order. It drops itself as a copy of that DLL. So the malware knows actually where the DLL is, the fake DLL is, right? So it can proxy and stay hidden longer, right? It will do a persistent. Got the point, right? So program.exe, it needs an example.dll. So in this instant, what I have been explaining an example, the malware places itself a fake DLL in most of the all DLL search orders. Say for example, it will drop a Windows system DLL in the Windows System 32. It will drop a Windows system. It will drop also in the current directory. Every path it has been dropping. So every time if that particular exe going to execute, it actually use the fake DLL example.dll from any of these search order folders, and it is being persistent, doing the persistent behavior. So this kind of DLL search order persisting mechanisms also exist so far in this digital world. So how we are going to detect? So we are going to detect this during the malware analysis if the malware drop a DLL into an unusual locations, right? If it has been dropping in some other locations, we have to check. So only we can detect that particular malware during the malware analysis. So in this module, we are going to do a demo, right? So in the next video, we are going to demo on system integrity monitoring. So I will tell the process of system integrity monitoring in this module, and we are going to demo in the next video. Right, system integrity, what is meant by system integrity monitoring? It will detect, it is a process where we are going to see the system changes before execution and after execution. That's it. So before execution, what is a system state we are going to capture, and after execution of the malware, I'm going to capture the system changes, and I'm going to subtract, I'm going to detect what are all the changes, right? So system integrity monitoring is nothing but it will detect most of the files and registry modifications. Here is the process I have been shown here in the picture. So first thing is you have to take an initial snapshot, right? Here the snapshot which is not indicating your VMware snapshot, not your virtual machine snapshot. Please make a note. It is a snapshot which has been done inside the virtual machine with the help of a tool called Registry. So what we are going to see in the demonstration short while. So please make a note, this snapshot doesn't mean that you are taking the snapshot in your virtual machine, right? It is the snapshot which has been done by a separate tool called Registry. I will show you in the demonstration. So the first thing is what we are going to do is take an initial snapshot, right, of the system, and we are going to execute the malware. We are going to wait for some time to do the malicious activities of that particular malware, and we are going to take a second snapshot, right, and we are going to compare the snapshot, right? So from the initial snapshot, I am going to compare the second snapshot after execution of the malware, right? I am going to find, I am going to detect, I am going to find, I am going to monitor all the files and registry modifications, and also as well the network modifications. Here in this case, this system integrity monitoring, this is a very important process in dynamic analysis, right? So here in this system integrity monitoring, it will mostly show the file changes, registry modifications, network traffic generation, everything we can see. But some modifications we couldn't see in this technique, system monitoring process. So what are all the things we couldn't look out? The first one is rootkits. Here right, rootkits is used by the attackers to hide their files, registry keys and network connections from the tools on the sandbox. So what are all the tools we have installed in our sandbox? And the attackers or the hackers, the malware authors will use this technique called rootkits to hide their files, registry keys and network connections. So some kind of advanced rootkits will operate at a very low level in the kernel level itself to hide their stuff, to hide their presence actually. So if it has been rootkitted, if the malware is actually rootkitted, you please make a surf on internet what is meant by rootkit. So this is actually the definition. They will use this technique, and malware author use this technique to hide their files where the system, the tool couldn't, what we have been using couldn't detect. So some rare cases occurs. So some rootkit, some advanced rootkit may also operate in a very low level, in the kernel level also, to hide their stuff. So our tool in the sandbox won't detect. So this is the first disadvantage. Second one is temporary file. So temporary file, which is nothing but the files that have been created and removed between the two snapshots. So it is actually the temporary file which is present in our systems where the folder has been created, and while execution some file will be dropped in that particular temporary folder, and the folder has been deleted. It remains for some time and it got deleted. So it is a file that are created and then removed between the two snapshots. First, say for example, first snapshot taken, we have been executing the malware here, right? So malware creates a file, then deletes the file. Second snapshot taken, two snapshots are compared, no evidence of the temporary file ever executed. So this won't be shown in the results. So in this picture, it has been clearly mentioned, we have been taking the initial snapshot, malware is created, and the folder or the particular file has been deleted in that folder. The folder will be deleted, or the files in that folder will be deleted. The malware file will be deleted. If it is been deleted, if it is been did a function on that particular temporary folder, then there will be no evidence of having that, a file or folder in the snapshot. So this is how we couldn't see the two kinds of things, in the dynamic analysis of system integrity check, rootkits and temporary files. So it is not a such much a big deal. Most of the malware authors have been not using much this kind of technique, so don't worry about that thing, right? So and so this is what I have to share in this module, system integrity monitoring. We are going to see as a demo in the next video, right? So thank you all.